Hello friends, welcome to H2 Academy. In the last lecture we have discussed up to question number 14. So we will discuss question number 15 onwards in this particular lecture. So basically we are discussing the problems on the vector identities. So let's start our discussion. So for solving such type of questions, there are important identities, there are important results that we have to take into consideration. So let us go through that first. Okay, so let us remember these results. First one is del dot r vector. Okay, del dot r vector is equal to 3. Secondly, del cross r vector, this is equal to 0. Okay, third one. So we have gradient of f of r equal to f dash r into del of r. Third one. Fourth one. We have gradient of r, that is del of r is equal to r vector upon r. Okay, so this we can write as this is f dash r vector upon r. These important results that we have to take into consideration while solving such type of questions. Okay, so let us write down here for the ease of understanding. Okay. So we have first one is del dot r vector is equal to 3, that is divergence of r vector. Secondly, curl of r vector is equal to 0. Third one, this is gradient of function fr, this is equal to f dash r, differentiation of that function f gradient of r, that is del of r. Del of r is r vector upon r. This is f dash r vector upon r. Let us write down here. We have this is equal to dash r vector upon r. Fourth one. Fourth one is this is fourth one is gradient of r. This is equal to r vector upon r. Okay. These important results that we have to take into consideration while solving such type of questions. Let us solve these questions one by one. Okay. Okay, so we have the first question. We have to find the gradient of phi. Phi is given by this particular expression and we have to find del phi. So let us solve this. First one is solution of 1. Solution question number 15. So we have the given as phi is equal to x square plus y square plus z square to the power minus x square plus y square plus z square power 1 by 2. Okay, and we have to find gradient of phi and mod of gradient of phi. Let us solve this. So we have let us consider, so we have let x square plus y square plus z square is equal to r square. So from here we have the value of phi as phi is equal to r square to e to the power minus r square power 1 by 2 is equal to r square e to the power minus r. This is the value of phi. So we have to find the gradient of phi. So we have the gradient of phi we have to find. Okay, so this is equal to gradient of r square into e to the power minus r. Okay, and we have gradient of phi as gradient of phi is equal to I del upon del x plus j del upon del y plus k del upon del z to phi. Okay, and this is equal to I del phi upon del x. This we can write as del phi upon del x I cap plus del phi upon del y into j cap plus del phi upon del z into k cap. This is equal to del of phi, that is gradient of phi. Okay, and we have the phi as r square e to the power minus r. Okay, so from here, from this expression, we have, let us differentiate this. The 2x is equal to 2r. Let us differentiate this expression with respect to x. 2x is equal to 2r del r upon del x. So from here, del r upon del x is equal to x upon r. Del r upon del y is equal to y upon r. Del r upon del z is equal to z upon r. Okay, so from here we have, let us find the value of del phi upon del x. So we have the value of phi as this one. We have value of phi as r square e to the power minus r. So from here, del phi upon del x is equal to del phi upon del r into del r upon del x. Let us find del phi upon del r. So del phi upon del r, let us differentiate this by parts. So we have this as r square into differentiation of second function, that is minus of e to the power minus r plus 2r into e to the power minus r into del r upon del x is x upon r, x upon r. This is equal to, let us take r common, r e to the power minus r common, r e to the power minus r into x upon r. This gets cancelled. We have del phi upon del x as, so we have del phi upon del x is equal to, this is 2 minus r e to the power minus r into x. Similarly, del phi upon del y is equal to 2 minus r e to the power minus r into y. Del phi upon del z, this is equal to 2 minus r e to the power minus r into z. Okay, so let us place this here, the values of del phi upon del x, del phi upon del y, and del phi upon del z. So we have the gradient of phi as del phi upon del x is this one. Let us take 2 minus r e to the power minus r as common. Okay, so we have this as, the left out terms are x, y, and z, and with that we have this I cap, j cap, and k cap. This is equal to x into I cap plus y into j cap plus z into k cap. X I cap plus y j cap plus z k cap. This is equal to del phi is equal to 2 minus r e to the power minus r into, this is r vector to r vector. Okay, let us take the modulus of this del phi. This is gradient of phi. Modulus of gradient of phi is 2 minus r, and e to the power minus r is scalar. So this will come out of this modulus. 2 minus r e to the power minus r, and this is modulus of r. Modulus of r is this one, r. So this is equal to r times of, this is r. So this is 2 r e to the power minus r into r. Okay. So modulus of del phi, modulus of del phi is equal to r times of 2 minus r e to the power minus. Okay. Now let us discuss question number 16. Two more important results that we have to remember this. Remember about this. Just write down here. This is fourth. This is fifth one. Fifth one is divergence of phi a. Okay. So phi is a scalar and a is vector. Phi is a scalar and a is vector. So this is equal to del phi dot a plus phi times of del dot a. Okay. Secondly, sixth one. Sixth one is del cross phi a is equal to del phi cross a plus phi times of del cross. This phi is, we have phi as a scalar and a as, okay. Now let us solve question number 16. Number 16. So we have this as divergence of Rn r vector equal to n plus 3 into r to the power n. We will use this expression, divergence of phi a. Okay, this is similarly like this. So divergence of this is del dot r to the power n and r vector. This is, let us take this as phi, this as a vector, and use this expression. Okay, so we have del dot phi a is equal to del phi dot a plus phi times of del dot a. So we have this as del dot, this is r to the power n is a scalar and r vector is vector. Okay, so in this expression we have the phi as a scalar quantity and a as vector quantity. So we have this as r to the power n into r vector, del of rn, okay, del of rn dot r vector plus phi times of phi is rn, del dot r vector. So we have del dot r vector is 3 and we have del of Rn, this gradient of Rn. Rn is a function of R. This is similar to this expression, this one. We have del of gradient of Rn equal to f dash R to gradient of R equal to f dash R into R vector upon R. F dash R is Rn minus 1. Rn minus 1 R vector upon R. This is del of Rn. Del of Rn is, okay. So we have this as, let us place this value of this here. So we have nr n minus 1 r vector upon r dot r vector plus r to the power n, this value del dot r is 3. This is equal to nr n minus 1 r square upon r plus 3rn equal to, this gets cancelled. Have nrn plus r to the power n equal to n plus 3 r to the power n divergence of r to the power n of r vector. Okay, now let us discuss question number 17. So we have this as divergence of r to the power n r vector as n plus 3 into rn. We will use this result. So we have this as del dot rn, divergence of rn r vector is n plus 3 r to the. Now let us use del square rn r vector. Let's discuss question number 17. Del square r to the power n r vector is equal to n times of plus 3 r to the power n minus r vector. Okay, so we can write this as, we have del square r to the power n r vector equal to del times of del dot rn r vector. So we have this as del times of rn r vector, gradient of n plus 3 r to the power n equal to n plus 3 times of del of rn. Let us take r to the power n as function of r. We have del of f of r is f dash r del of r equal to f dash r del of r is r vector upon r. Del of r is r vector upon r using fourth expression, r vector upon r del of f r. Okay, so we have the value of f r as r to the power n. So this is equal to nr n minus 1 r vector upon r n minus 2 of r vector. So let us place here del of f r, that is del of r to the power n. Let us place the value here. So this is equal to n plus 3 times of nr n equal to n times of n plus 3 r n minus 2 of r vector. We have to prove this value. So del square r to the power n r vector. Okay, now let us discuss question number 18. Question number 18. Prove that divergence of r vector upon r cube equal to. How we can solve this? So we have the expression. We have del dot phi a. Del dot phi a. This is del dot phi a equal to, where phi is a scalar and a is vector quantity. So this is equal to del phi dot a. Divergence of phi a. Del phi dot a plus phi of del dot a. Okay, so here we have, let us compare this with this expression. Let us take phi as 1 upon r cube, a as r vector. This is equal to del of 1 upon r cube dot r vector plus phi times of phi is 1 upon r cube. 1 upon r cube del dot r vector. Okay, del of phi 1 of r cube. Let us consider f of r as 1 upon r cube. Del of fr equal to f dash r into del of r equal to f dash r into del of r is r vector upon r. So from here, this is equal to r to the power minus 3. F dash r is f dash r dash r is minus 3 r minus 3 upon r4 r vector upon minus 3 upon r5 r vector. Okay, this is del of f r. Let us place the value here. We have this as, this value is minus 3 upon r5 into r vector. We have this as minus 3 upon r5 r vector. The value of this one, del of 1 upon r cube dot r vector plus 1 upon r cube into 3. This is equal to minus 3 upon r5 r square plus 3 upon r equal to minus 3 upon r cube plus 3 upon r is equal to 0. So we have the value of del of divergence of 1 upon r cube equal to. Now let us discuss question number 19. Let us discuss question number 19. We have this as proved that divergence of r vector r cap equal to divergence of del dot divergence of unit vector r. Okay. Divergence of r cap is equal to, this we can write as r cap, we can write as r vector upon modulus of r equal to r vector upon r. Divergence of 1 upon r vector. Let us lose the expression. Let us take this as phi. This as a. We have del dot phi a equal to del phi dot a plus phi times of del dot a equal to del of 1 upon r dot a is r vector plus phi times of phi is 1 upon r. This is del dot r vector. Del dot r vector is 3, and this we can write as differentiation of 1 upon r. So we have del of fr as f dash r in r vector upon r. This is equal to f dash r. This is minus 1 by r square r vector upon r dot r vector plus 3 upon r equal to minus 1 by r square upon r plus 3 upon r. This gets cancelled. Minus 1 upon r plus 2 upon r, 3 upon r is equal to 2 upon r. Del dot phi a. Del dot 1 upon r vector equal to del dot 1 upon r vector equal to 2 upon. Okay. Now let us discuss question number 20. Let us discuss question number 20. Okay, so prove that the vector fr into r vector. Prove that vector fr into r vector is irrotational. We have we have the expression. Use this expression. Curl of phi a. So we have when a vector is said to be irrotational, then the curl of that vector is 0. Okay, so let us consider this as phi a. Okay, so let us take the expression curl of phi a equal to, let us take fr as phi, because phi is the scalar quantity and r is the vector quantity. This as a. Let us find this. Suppose now, after finding the curl of this whole vector phi a, if the result is 0, then we can say that the vector is irrotational. As simple as that. This is equal to del phi cross a plus phi times of del cross. We have del cross phi is fr and a is r vector, equal to del of cross r vector plus phi is f, del cross r. Del cross r vector is, this is straight away 0. Now we have del of fr is f dash r gradient of r cross r vector. Gradient of r is r vector upon r. So this is equal to f dash r vector upon r cross r vector, equal to f dash r upon r. This is r vector cross r vector. The cross product of same vector is 0. So r cross r is 0. So this is straight away 0. So we have del cross fr r vector. So the curl of this vector fr and r vector, curl of this vector fr r vector is 0. This means this fr, the vector fr r vector is irrotational, because curl of r vector. Okay, so we have discussed up to question number 20. Thank you.